For today's melt, I'll be using these crankshafts. They've come from lawnmowers, and you're probably wondering why I've cut the timing gears off these three crankshafts. It's because I'm going to use these gears and the ones that came off here for a future project. Here is all the scrap. It's been cut up to bite-sized chunks, as I will be using the A6 crucible. The metal has been added to the crucible, and we've got a piece that's sticking above the crucible, and we'll see if it burns or not. This mould is a test mould for the crankshafts. We'll see how well it casts. This is a cylinder I need to make. Now you'll notice there's no vents on the core, and there's no vents in the sand mould itself. So I'm going to cast it up and see if it machines well, but also to see sure there's no flaws or blowholes in the resulting casting. Adding ferrosilicon. Ready to take the crucible out. Here are the leftover pieces in the ingot. You can see where they've hit the steel mould. They are chilled, but the rest is grey. Here are the larger ingots. They're chilled also, but probably less because they're more mass, but they've still chilled when they've hit the steel mould at the bottom. Here is the wedge test from the crankshaft melt. It's totally grey all the way through. The ferrosilicon has done its job, and what I'll do, we'll drill through the edge and see how soft it is. Couldn't be any softer than that. Here is a close-up of the drilled hole in the wedge test. This is the only mould that has a core in it. We'll see how this one turned out. Here is the test casting I made from the lawnmower crankshafts. As you can see, it's just a simple ingate in here. But what someone's going to ask is, why didn't I put vents in these top parts of the mould? Well, the simple answer is it doesn't need it. To show you, there's a mark I made. There's the very top of the mould. There it is, it's only barely above my finger, and that's all it's needed to fill up that mould. Also here, it has shrunk, there's a depression, and that is enough to feed it. There's no point in putting a long sprue on it to try and fill it up the mould. Casting has machined up really well. All these surfaces, the bore, there are no blowholes, slag inclusions or anything like that. But I've got one more test to see how good this casting is. Okay, this is the final test for the steam engine cylinder. I've cut it in half and sectioned it. I'd like to see exactly what it looks like. What I'm after, is there any blowholes in the bore? I can't see any. What I am also looking for is, this is where it was gated, to see if there's any shrinkage porosity, and there is none. And now we'll have a closer look at the two halves. So now I'm totally satisfied that this casting turned out perfect, which means I can go ahead and machine the other 4 castings I poured, and they will be the subject of future videos. So what happened to the metal that was charged above the lip of the crucible? Well, absolutely nothing. I charged 6.6 kilograms of iron, and all the castings I weighed afterwards was 6.512 kilograms. So that works out 1.4% loss. So I've come to the conclusion it makes no difference whether you charge a metal above the crucible lip or below the crucible lip.